continuing on from yesterday. So basically, today we're just doing what we learned yesterday for more application type questions. And really, you're not going to need to always use 0 and 1 for your mean and standard deviation. So if you take a look at the solution key in Schoology, it converts all these values to z-scores. That's why is that? Because older versions of the calculator would just do the z-scores, and then use that formula from yesterday to convert it to an actual data value. Also, from before, if you weren't allowed a calculator, you had to do z-score tables that were given to you. And those are all in z-scores. So you would have to convert a data value to a z-score and then look at the table to get the area for that. Or the probability. So we're going to do it directly into our calculator using the data values. Okay? If you take a look at the answers in Schoology, they have not gone directly. So follow along. This is the easier way. So it says in the first one, we looked at one like this the other day. So in this case, the light bulb manufacturer produces 35,000 light bulbs. From past experience, the mean life of the light bulb is 900 hours. Standard deviation is 50. Determine the percentage of light bulbs that will last between 825 and 875. So that is less than the mean. So I recommend you do a little bell curve like this. Label the mean, and then draw the area that you're looking for. So 875 stays about there, 825 is about there. Okay? We're looking for the percentage. In our calculator, will give us the probability. So a number less than 1, so we multiply by 100. So, in this case, norm CDF, and then our lower boundary is 825, upper is 875. In this case, notice how I'm not converting these to z-scores, right? So, if I'm not converting them to z-scores, then I have to use the actual mean and the actual standard deviation. So if you have a newer version of the calculator, it's vertical, right, and you enter these. This is sort of faster. So in a written response, this would be your work, or you can write out what it is vertically, but I would just write it like this. Okay, so calculator, remember it's in distributions. It's normal CDF. Oh, I guess I put norm there. It's normal CDF. Now, our left boundary is 825. Our right is 875. Our mean now is 900. Standard deviation is 50. Okay. So I'm just entering that in, pasting it. It goes to exactly that. Enter on that. And this is 0.24173. Go to a number of decimal places. So then your percent, so this is the, you can call it the area or the probability. And then percent is times by 100. Okay, and did it say what to round to? It didn't say what to round to. Let's go to one decimal place. So no converting to z-scores. Just use the values that are given. Okay. Then it says, what is the number of light bulbs that will last between 825 and 875? We now have the percent percent of all the light bulbs. How many were manufactured? 35,000. So you want to take 35,000 and multiply. I would go use what's saved in your calculator. So as many decimal places as you have. So I'm going to go back. I can either go back and multiply this by 35,000 or take this, multiply by 35,000 and divide by 100. So totally up to you. If you don't have that capability to go back up, then I would just, you can divide this back to the decimal form and then multiply by 35,000. Okay. Now, can't have part of a light bulb, so we would say approximately 8,461 volts. Okay, the next one is the probability, so that we're not going to convert to percent. It's a probability that a bulb selected at random will last less than 920. So remember, this is 900. So 920 would be past there, and we want this area. Okay. This is 920. Question? So, normal CDF, in this case it's probability, normal CDF, lower boundary here, because this says less than, so negative 1 times 10 to the 99, upper boundary is 920, mean is 900, standard deviation is 8. Okay, so enter that into your calculator. And again, it didn't say what to round to. Probably at least 2 decimal places. Right? If we go to 2 here, it would be 0.66. That's the probability. Okay? Percentage would be 66%. The area under the curve is 0.66. Always less than 1. Okay. This next one, a study showed that the mean duration of a certain strain of flu virus was 12 days with a standard deviation of 3. If you caught this type of flu, what is the probability to the nearest proof that it would last longer than 17 days? So mean is 12, standard deviation is 3, right? And it says longer than 17 days. So let's say 17 is there. We want to know what that area is. Okay. So the area is the probability. So probability here is normal CDF. Now our left boundary or lower boundary is 17 and our upper one is infinity. Remember, infinity in our calculator, that's the closest we can get. Mean is 12, standard deviation is 3. So now 17 lower. 1. Remember, you can do, instead of times 10 to the 99, you can go second E here, comma. That means times 10 to the 99. Okay. In this case, 12 is our mean, and 3 is our standard deviation. It saves the previous mean and standard deviation, so we've got to change those in this newer version. To the nearest hundredth, 0. Well, I'm going to write a few decimal places so you can check. So probability to the nearest hundredth. What's going on? All good. Probability is a number less than 1. So you leave it, you don't multiply by 100. Then between 13 and 15 days, will be here 13 and 15. Okay. And so, lowers 13, uppers 15 means 12, standard deviation is 3. So second distribution, normal CDF, lowers 13, uppers 15, 12, 3, right, and then take that. There's that 1. Okay, next one. So, from extensive testing, an appliance distribution company knows that the average life of toast and toasters is 4.2 years, and the standard deviation is 0.65 years. The company does not want to replace under warranty more than 8% of the toasters that are sold. So, when you buy something, sometimes they'll say, this is under warranty for 2 years. That means you can return it and get a brand new one, right? So that's what they're looking for. They don't want that to happen for more than 8% of the toasters. Okay, so they want to know what of the lifespan of a toaster, how many, what the time period is for the lifespan of toasters in the lowest 8%. Okay. We don't want to go any higher than that. So, what guarantees the nearest necessary year should the company offer? So here, our average lifespan of the toaster, 4.2. think that's a little low. Most posters less. You know, at least the ones I have. But in any case, 4.2 standard deviation is 0.65. Okay. So, we want to look at, they don't want to replace more than 8%. So we want the lower end to figure out what 8%, what time period here, where this would be 8%. Okay? Well, that's the same as 0.08. So now we're given the area, what a percent of the probability, you can show it anyway. And now we have to work backwards. Yesterday we worked backwards to get the z-score. But as I said, you don't have to get the z-score and convert it, because your calculators will give you the data value. So we want to go from the area to the actual value of years. So that is inverse norm. So yesterday it was z equals, today is x equals, the actual data value. Okay, the first value that you enter is the area starting from the left, unless you have a newer version of the calculator where you can tell which tail it is. In this case, it's the left anyway, so it's good for all calculators. And instead of 0 and 1, we put the mean number of years and the standard deviation. So what it looks like on your calculator, you go under, you go to number 3, inverse norm, and you put in the area. And instead of 0, 4.2 is your mean, and 0.65 is your standard deviation. Okay. So that's what it's going to look like on all calculators, no matter what. Okay, so our x value is 3.2867. So 3.2867 years. Okay. It says to the nearest necessary year. So in this case, does not, so this value here would be 3.28. If they reduce that to 3 years, then they would be replacing less than 8%. So rounding this down makes sense. Okay. They're not going to give you warranty at 3.2 years. They're going to say 3 years, sometimes a half year, but usually it's probably a year. Okay. You're not going to go to 4 years, because then that's, you're going to have to replace a lot more papers. Okay. And simple aspect or okay, it was found that 37.7% of the fruit harvested at fruit harvest farms had a mass of less than 135 grams. If the mean mass of the fruit harvested was 146, determine the standard deviation. Okay, so now you don't know all of the information. So we might have to use z-scores in this one. So the mean here is 146. But we don't know the standard deviation. Okay, we know for 135 grams, let's say that's here, that represents here 37.7%, which is 0.377. So there's not a thing in your calculator. You can play around with it. Maybe there is a way to go in and just get the standard deviation, but I don't think there is. So you have to do a little bit of extra work in this case. Okay. So we know this area, so we could get we could use our 0 and 1 for z-scores and get the z-score here, right? So if we go inverse norm, so z-score, so 0.37701. Remember the z-scores, mean is 0, standard deviation is 1. Put a few decimal places, keep it in your calculator. Okay, so that corresponds to 135. So remember our formula from yesterday? X minus mu over standard deviation. Okay, so if we knew, we could find the z-score if we knew all of these pieces of information. Now, what do we know? We know this. We know this, 135, 146. Z, we now know. And so we can solve for our standard deviation. Rearranging this gives you that formula. These just interchange, right? So, standard deviation for our x value is 135, our mean is 146, divided by the z-score. And again, keep it in your calculator. So I can go 135 minus, actually, you want to do it all at once. Bracket, 135 minus 146. Close that. Divide by previous answer. And so the standard deviation, it doesn't, oh, here's 10. 35.1. Last one here. The marks of a large number of students have been represented on a standard normal distribution curve. The values given represent the number of students in each area, not the area. The whole thing is one. But that's the number of students. Determine the value of Z1 to the nearest 100. So notice how we're talking about Z. So that's a Z-score. All right? Mean is 0. What's the Z-score? If there's 452 students in this area and 1,250 in the other area. How many students in total? 2,500. Yep. Right? This cuts it in half. So this is 1,250. So this has to be 1,250. So total number of students. So, a couple of ways. If you have the newer version of the calculator, you could then use your area as, well, in a way you can do it no matter what version of the calculator, but find this entire area as a decimal. So what is that? This total here is what? 1702. Okay, So what percent is that out of 2,500? So 1702, 2,500. Okay, so those of you that with the newer version, that would be a right tail for 0.6808. If you don't have that, so sort of my version, you're doing inverse norm. You could do that saying 0.6808, but remember it's assuming that that's coming from the left. So when I do this, I will get here, get a positive z-score, but really it's got to be flipped, so it's going to be negative. So my version of the calculator, the Z1 would be equal to negative inverse norm 0.680801. So negative 0.47. If you have my version or older versions as well. Okay. Alternatively, for this version of the calculator, I could do Z1 equals inverse norm. And you could actually even put it in your calculator like this, but 1 minus 0.6808. Right? To get that left part here. The whole thing's 1. If I know this is 0.6808, then this will be 1 minus it. .3192. And so if I do that, inverse norm, 0.3192. Negative 0.47, which is there. Okay, so some slightly different ways of doing it. Okay, depending on your calculator. I think that was the last question.